Okay, so today we're going to look at, so we have looked at in the past, the difference between linear and exponential. Right? Everybody shake your head, yes? Yeah, yeah. Okay, during the exponential equation unit, we looked at the differences there. Today we're going to throw quadratic in there as well. Okay? So I already have my tables filled out. That's why I don't have it up on the board. But the three tables down there, okay, one represents a linear function, one represents an exponential function, one represents a quadratic function. If you would, please, together with your groups, go ahead and fill in the tables and start talking about, or fill in the tables, graph them, and then if you would start talking about the general idea of what a linear, exponential, and quadratic function, table, and graph look like. Okay? All right, so I'll give you some time to fill in the graph or the tables and the graphs. I'll kind of discuss a little bit. Go ahead. Okay, so let's take a look here. Okay? So the first table should be pretty straightforward for you. Just plugging the values into t, they're actually exactly the same because we don't manipulate t at all. The second table was probably the most challenging for you to do on your calculator. Make sure you find your exponent button. Make sure that the decimal t value that we're looking at there is the one that goes in for the exponent. Okay, so make sure your values match there. And then for the third column, we are just squaring the t value. So again, you'll need to know where your exponent button is, or most of you probably just have a squared button on there, so you can do that. Okay. So what we need to be able to do, what I want you to get out of today's lesson is I want you to be able to look at any function, any table of data, or any graph and tell me, is it linear, exponential, or quadratic? Okay. So I think graphically is probably the easiest for us because we're pretty comfortable with that. I think you all know what a linear function looks like, right? It just is going to become a straight line. So we have that one here. The difference between quadratic, so let me actually pull this up. Oh, I froze it, didn't I? Hold on a second. There we go. So we have our we have our linear function here, which is the straight line. The difference between exponential and quadratic. Remember, exponential is going to start off low and then skyrocket up, or sometimes it'll skyrocket down, but it's going to stay pretty level, and the growth is going to be very, very small on one side, and then it's going to skyrocket on the other side, either up or down. Different than a quadratic, right? Because a quadratic is going to start high, come down low, and go back up high, or vice versa. It will make the upside down U shape if it's opening down, right? So that's the difference there. It gets a little more challenging when we are looking at functions, okay, when we are actually looking at the equations. Linear is probably the easiest one to recognize. What does linear not have? No. If we're just looking at the functions. So we're not looking at the graphs anymore. We're just looking at the functions themselves. What does linear not have? What? Nope. So up here in the functions. Right here, right here, right here. What does linear not have? Somebody just said it. An exponent, right? So linear does not have an exponent. So the first one there would be linear. The difference between exponential and quadratic are a little more challenging. They both have exponents. But with exponential, the one in the middle here, remember our exponent is a variable, okay? So the exponent has to be a variable for exponential. And then here we have quadratic. It is an exponent of 2. Okay, so quadratic is an exponent of 2. Exponential is an exponent of a variable. Okay, any questions there? Probably the most challenging to figure out is the table of data. So how does linear data grow? What kind of verbiage do we use for linear data? You guys remember? Quick 30-second conversation in your group. How does linear data grow? So you can flush it out. See if you can throw together some ideas. What'd you guys come up with? Yeah, constant rate of change, right? So if you look, if we dumb it down to layman's terms, that's plus a number, plus the same number, plus the same number, plus the same number, right? We're adding the same thing. As long as the t values or the x values are remaining constant, we should be adding the same number to the y values every time, right? That's how we know we have linear data. Exponential data, remember our y value should have some kind of ratio to them. So instead of adding the same number every time, now we're multiplying the same number every time. Okay? Quadratic data, that one's new to us. If we look at quadratic data, the second differences are the same. So the first differences are the same with linear. That's the constant rate of change. What is constant with quadratic is the second difference. So the change, follow me here, the change is changing the same way every time. The change is changing the same way every time. So maybe it's going up 2, then up 4, then up 8. Is that right? No. It would have to go up 2, then up 4, then up 6, then up 8. So the change is changing every time. That's quadratic. Yeah. Yeah. Sorry. I had to get that right in my head there for a second. Okay. So that is basically what I want you to know. The second page is just kind of a set of notes, all kind of stuck together, exactly what I just said. Okay, so we see up at the top, we see the differences between the functions. Okay, so let's do a little bit of highlighting here. Okay, so let's start with, let me do the highlighter. Okay, so here are our functions. So you should be able to compare those three functions. You should be able to compare the graphs. Okay, and then you should be able to compare all the way down at the bottom the tables of data. So this is essentially how the tables of data are moving. So those are the three things you should be able to compare. You should be able to compare the functions, be able to look at a function and tell me what it is. You should be able to look at a graph and tell me what it is. And then you should be able to look at a table of data and identify one of those three types of changes. Okay, any questions? All right. The rest of the time is yours to work on prep.